Okay, so we are in lesson 3.4. We're going to talk about some of the properties, or really some of the definitions of the different types of quadrilaterals. So our learning goal for this lesson is that students will classify quadrilaterals according to their sides. If you want to look at our success criteria for this one, it's really just being able to classify and identify the different types of quadrilaterals, but based on the information that's given. So in this part, we're just going to go over the definitions of the different types of quadrilaterals, and then in class, we'll do some activities where we have to use those definitions to make conclusions about the quadrilaterals. Okay, so let's just start with the basic definition of a quadrilateral itself. Quadrilateral is just any polygon that has 4 sides. So we can see this polygon has 1, 2, 3, 4 sides, therefore it's a quadrilateral. Alright, so now let's start talking about some of the more specific types of quadrilaterals. A right quadrilateral is a quadrilateral that has at least one right angle. So it might actually have more than one right angle, but there has to be at least one right angle to know that it's a right quadrilateral. Just like we have a right triangle has a right angle in it, you can also have a right quadrilateral. It doesn't have to be all the angles are right, however. So we can see we've got our right angle marked here with a little box, so we know that it's right. All right, so the next type of quadrilateral is a parallelogram, and we've kind of talked a little bit about parallelograms. We've used them to draw planes that we're trying to represent in another dimension. But if we're just talking about a flat figure, a parallelogram is a figure whose opposite sides are parallel. Now you want to look for the arrows that are on each of the opposite sides to know for sure whether or not they're parallel, or some other information that tells you yes, the opposite sides are parallel. So for example, if you knew the coordinate points of A, B, C, and D, you could find the slopes of the sides. And if the slopes of the opposite sides were the same, you would know that they were parallel. So there has to be some information that allows you to conclude for sure that those opposite sides are parallel. If they are, then it's a parallelogram. All right, now there's actually several types of special parallelograms. The first of which I'm going to talk about is a rhombus. So a rhombus is a parallelogram where all 4 sides are congruent. So you can see in this diagram here we still have segment AB is parallel to CD, and AD is parallel to BC, so these two over here. So you can see we have double arrows here and single arrows there because they're different sets of parallel sides. However, all 4 sides are congruent. So AB, see that has a single mark, is congruent to CD. Single mark is congruent to BC, and that's also congruent to AD. So all 4 sides have a single mark. That means all 4 sides are congruent to each other. All right, the next type of quadrilateral is, of course, a rectangle. And we've talked about defining a rectangle before in class. Remember that, right? It's kind of hard to define something like a rectangle when we already know what it is. But the specific definition of a rectangle is a parallelogram with all congruent angles. Now, since it is a parallelogram, that means its opposite sides must be parallel. So here you can see we've got the parallel markings here and here, right? Oops. So double arrows, single arrows here, single arrows here. So opposite sides have to be parallel. The other thing that has to be true is all 4 angles have to be congruent. But since it's a quadrilateral, the interior angles must add to 360. All right, well, if all 4 have to add to 360 and they all have to be congruent, then 360 divided by 4 is 90, so all 4 of them must be 90 degrees. Now that's really the definition, is just this piece right here. EF is parallel to GH, EH is parallel to GF, and angles EF, G, and H are all right angles. But it turns out, of course, that not only are the opposite sides parallel, but the opposite sides are also congruent. All right, so our next figure is a square. You guys know what a square is, of course, but the real definition of a square is that it is a regular quadrilateral. Remember, regular means that all sides and all angles are congruent. So all four sides are exactly the same, and all four angles are exactly the same, and all four angles are right angles. So one way of defining a square is as a regular quadrilateral. Another way of defining it is as a parallelogram with congruent sides and congruent angles. So opposite sides are still parallel, but now we have all four sides congruent and all four angles congruent. So we got all of this different information that we could conclude. EI is parallel to HJ, EH is parallel to IJ, and then segments EI, HJ, EH, and IJ are all congruent, and angles EIJ and H are all right angles. All right, just a few more to talk about. The next one is not a parallelogram anymore. It's a trapezoid. And a trapezoid is not a parallelogram, but it's similar. But this time it's a quadrilateral that has exactly one pair of parallel sides. That means one pair of sides are parallel, and that's it. The other pair of sides cannot be parallel. So in this diagram, we have KL is parallel to MN. And so this is a trapezoid. Now, one of the things that I want you to be aware of is that a trapezoid does not have to look like this. This is often what people think of when they think of a trapezoid, but this is actually an isosceles trapezoid. An isosceles trapezoid is a trapezoid that has two congruent sides. The congruent sides cannot be the parallel sides. So you can see we got the parallel sides on the top and the bottom, and then we have the congruent sides on the left and the right. And of course, that's just a matter of how you draw the diagram. It doesn't have to be the parallel sides on the top and bottom. You know, your trapezoid could be drawn like this. Um, but what does have to happen is that the congruent sides are not going to be the parallel sides. So this is an isosceles trapezoid, two congruent sides, but this is just a regular trapezoid that only has one pair of parallel sides. All right, we got one more quadrilateral to talk about, and we're done. The last type of quadrilateral is the kite. And I know you've seen kites flying in the air, but the specific definition of a kite is a quadrilateral that has two pairs of adjacent sides that are congruent, but no opposite sides can be congruent. So if we look at this diagram, here's what I mean. Side OP is adjacent or next to side OR, and these two sides are congruent to each other. So that's one pair of congruent adjacent sides. Then we have PQ and QR, and these two sides are congruent. So that's my other pair of congruent and adjacent sides. But notice, looking at the little tick marks that we've used, we have one here and two here. That means that side OP is not congruent to side RQ. Side OR is not congruent to side PQ, and that's this second part of the definition. No opposite sides are congruent. Okay, so what I'd like you to do now is just go through and put in your level 1 questions that go along with all of these different definitions, and then think about maybe some level 2 or level 3 questions that help you put all of this information together and include those in your Cornell questions. After you've done that, write a brief summary. You don't have to go over every single definition in your summary, but maybe try to draw some conclusions about some similarities within the figures that's going to help you use that summary as a tool to remember what's going on with all of these different types of quadrilaterals.